Welcome back once again to the light and switch tutorial. When we last finished the previous piece, we had our light application responding to toggle messages and other on-off cluster messages by setting the LED according to the state of the on-off cluster's on-off attribute. And we were sending our toggle message by going into the console of the switch device and manually entering commands like zcl on-off toggle and then send 011. But what we'd like to do is look at how we're going to get those commands into some kind of event-driven state machine that can be initiated by a button press rather than being manually entered from the command line interface, more like a real application would be doing. What we need to do now is focus on our switch application and try to understand how we could get control of some of the buttons. So let's begin by going to our MySwitch.isc file that we created in the earlier part of these exercises. So you can put away your light configuration. We're done with that now. And if you've done this recently, you should be able to say File, Open, look at your recent configurations, and find the My Switch configuration. Now let's see if we can find the top level interface for dealing with buttons and see where we have to add our code. In the switch application, we had selected our plugins according to some of the defaults. And the one that we're most interested in here is one called Button Form Join Code under the Utilities section. You can see the name of the plugin along with the description, and it explains that the Button Form Join Code, which is currently enabled for this application, hooks up button 0 to have specific behavior based on its network state. This is the code that's responding for the button presses deciding to either form or permit joining depending on whether the device is in the network or out of the network. And in the case of the switch, it's joining rather than forming. Now what about button 1, the other button on the breakout board? Here it says this one isn't used and a callback is provided so that another module can use it if it wishes. Well, we need to understand what callback is being provided. The easiest way to do that is actually to look in the plugin information window for this plugin. You'll see that there's a list of source files. You can even double click on those to open up the source code that goes behind this plugin if you're curious what code is initiated to make this work. Instead of diving into that, let's just start by looking at the implemented callbacks and defined callbacks for this application. The implemented callbacks are the ones that come from AppBuilder natively that are now being overridden by this plugin, and the defined callbacks are those that originate inside this plugin. And if you enable this plugin, you have the ability to write code for those callbacks in your own callback C file. So if you were to disable this plugin, you would have to write your own code for the intrinsic AppBuilder callback Ember AF HAL button ISR callback, which is actually a direct wrapper for the HAL's own button interrupt service routine provided by our button.c driver, which wraps the low-level GPIO IRQs with edge-triggered interrupts, noting which button has been pressed and whether it was a high or low edge to indicate a button press or a button release. So the HAL button ISR callback is inside this plugin and is watching the interrupts when the buttons are pressed and released for either button. But what happens with button 1? Well, that's being passed along by the plugin to Ember AF plugin button joining button event callback. And that's the one that we're going to implement in our code to be able to manage button presses not already handled inside this plugin, namely those occurring on button 1 as opposed to button 0. So since this is an optional callback, we're going to now have to turn it on by going into the Callbacks tab and looking under the section called Plugin Specific Callbacks. And in that, we're going to see one called Button Event that says it's plugin specific to the Button Form Join code. You'll see the description and code behind that plugin on the right, which provides the function prototype and the list of arguments explained for you. You'll see it gives you the button number that we're referencing and a 32-bit unsigned button press duration in milliseconds so that you can take different action depending on how long it was between the button press and the button release. So you're not having to handle the press and release interrupts separately because the plugin's doing that for you, and then recording the total duration of the button press via this callback. So if you check the box to enable this callback, it allows you to take your own action when button 1 is pressed. In order to make sure that that actually gets into your project now that you've enabled it, you'll need to regenerate your AppBuilder configuration. I would recommend saving your AppBuilder config at this point. So click Generate to generate a new set of code. This will take a few seconds. And in the past, we just got the full list of files generated without any further prompting. But in this case, we're changing an existing set of project files, an existing configuration. So since there are some files that are going to be changed by our actions and things are being overwritten, we'll get a dialog that says that some files may need to be overwritten. And the important thing here, depending on what changes you made, you may have other files that are different than this list, but the key piece of information is the switch callbacks file. Note that by default, it doesn't want to overwrite this file. That's because it assumes you've already put your custom code here. So even though it's volunteering not to overwrite that, here we actually do want to do that because we want to make sure that that new callback shows up in that callback C file. So we'll say, yes, please overwrite this file. Go ahead and overwrite any other files that may have changed from your clicking around inside AppBuilder. If you've already added custom code to that callbacks file outside of AppBuilder and then you wanted to enable this callback, then the best thing to do is probably just to copy-paste that callback code manually into your new callback C file, because that's essentially what AppBuilder is doing. AppBuilder doesn't really merge that C code into your existing C code. So if you said that you wanted to generate the callback C file again and overwrite it, even if you'd put code in there, then you would lose any custom code that you had there. So be very careful when electing to overwrite your callback C file, especially if you have custom code there. If you do happen to overwrite it by accident, keep in mind that it does create backups of any files that have been overwritten. So you can still find a callbacks C back file, callbacks.c.bak, that provides the previous copy of your callbacks file before it was overwritten. Now you can bring up your MySwitch IAR workspace file, and if you had it open, it will prompt you letting you know that files there have been changed and you'll need to reload them. Once that loads, you will need to go into the callbacks code for the switch, which should be called myswitchcallbacks.c, and that's where you're going to add your custom code. So we have the button joining event callback, and that's where we're going to react to these button presses on button 1. Note that we're not expecting anything on button 0 because generally the plugin would handle that, but just in case, for future proofing, we're going to check on button number and make sure that it's 1. So we'll say if button number is 1, we're going to handle that case and ignore all other cases. In this example, we'll keep it simple and not do anything special based on button press duration, but you could do a more advanced example that does additional logic depending on how long the button was pressed until it was released. You might even take specific action if you get several button presses in a row by having some static variable that counts the number of times that you've come into this function since you took some action. But we're interested in replicating the behavior of the CLI using our button press. So we're going to do the equivalent of creating a ZCL toggle message, and then we're going to send it to the light on the target endpoint. And for reference, the CLI commands we were using to do these things were ZCL on-off toggle and send 0, 1, 1. So let's look at how we go ahead and create these toggle messages. The first thing we need to do is consult our API reference so we can see what kinds of interfaces are available for constructing these kinds of outgoing commands. We need an API that's going to build us up a buffer similar to what the CLI is doing. So let's go to our application framework API reference, not Ember ZNet API reference. And after bringing up that application framework API reference, you're going to not look at CLI, but instead the API. The CLI reference is just the list of available serial commands, not the code behind them. But now we want, instead of the general interface, something called the command buffer loading interface. This deals with loading up a ZigBee cluster library command buffer or response buffer, which can then be sent over the air using one of the app framework's send functions. That interface consists of functions that load and functions that send. So this list is going to be a set of generated macros made by AppBuilder at the time that you created your project. So it looked inside the XML dataset of all ZigBee cluster library commands and responses across all those different clusters in both the client-to-server and server-to-client directions, including those commands that are not cluster specific like read attribute, write attribute, discover attributes, configure reporting. And after determining what commands existed on what clusters and what their parameters were, it created macros that could allow you to pass each of the command's arguments as a parameter to that macro. And if you've extended AppBuilder with custom clusters, as per our extending AppBuilder video, you'd even have macros here available to construct custom cluster commands in your own custom defined XML. So since we're interested in creating the toggle message from the on-off cluster, we can just search for the word toggle here. And so under the list of on-off commands, we'll see an Ember AF fill command on-off cluster toggle. And that doesn't require any parameters because the toggle command in the on-off cluster doesn't actually have any parameters. The off, on, and toggle commands all are basic commands that are provided by the on-off cluster and require no parameters. If you click on the command link, you'll see that this is a command for on-off that performs the toggle function. So we'll come back to our code and use that API, Ember AF fill command on-off cluster toggle, to construct our command buffer. It doesn't have any data return, it just puts it into the global buffer, which you can then use with an Ember AF send function later on. Don't forget to add a semicolon. Now we're going to need to look for a send function that references that global buffer. For the sending portion, we'll go back to the API reference, and since we're not looking for one of the buffer loading macros, we're going to go back to the general interface, the same place that we found the read and write attribute commands, and we're going to look for functions that deal with sending messages. So scroll all the way down until you see the area that's called messaging. This has to do with everything related to sending messages within the Ember application framework. These are largely built on top of the low-level stack or EZSP APIs. So rather than asking the stack directly to send, say, a unicast message, you're going to the application framework and using a function like Ember AF send unicast instead of Ember send unicast. The advantage here is that the application framework can do certain things as a convenience, such as check to see whether fragmentation is required and break up the message appropriately. It can check to see if the message is going to fit. It can add additional options to the outgoing message, like encrypt it with the appropriate security if its cluster requires that, and do some other things that don't require the application to do as much pre-processing of the message before it goes out. If you're curious about what kinds of sending options are available at a lower level, you can look at the Ember Send Unicast API and the Ember ZNet API reference to see what this is building on top of. So now we're looking for a send function that deals specifically with the command buffer loading interface. And since we're sending from one node to one destination, we're looking for something called a unicast function rather than a multicast or broadcast. So we could use the Ember AF send unicast command, which would require the type of outgoing message, the index or destination ID where we want to send that, an Ember APS frame structure pointer, which would require specifying the endpoints, the cluster ID, and some other parameters, and then the array of data that we want to send. But this doesn't actually directly leverage the command buffer loading interface. As you can see, it asks you to provide your own message and message length. But since we already leveraged the command buffer loading interface, there should be some mechanism in the framework that knows what we built and how long that message content is in terms of bytes. So we'd like to be able to leverage that information in whatever function we use. Keep going. We have Ember AF send unicast with callback, which is basically the same as Ember AF send unicast with a custom function pointer that can be invoked when the transaction is complete. Ember AF send unicast to bindings, which also doesn't leverage the command buffer yet, but does take fewer arguments. So we need a function that has the word command in it because those are the functions that actually leverage the global command buffer. So something like Ember AF send command unicast would do the trick, or even Ember AF send command unicast to bindings, or any of the other Ember AF send command unicast functions. So now we want a function that can be used to send a specific message to a target with a specific node ID and a known set of endpoints. So we should be able to do this with Ember AF send command unicast, which just requires the method by which we want to send the message, the outgoing message type, and then an index or destination, which for messages that are being sent via a table, that would be a table index. For message sent directly to a node ID, that would be a destination node ID specifically. And if we click on the API, we get a detailed set of instructions that say that this sends the command prepared with the Ember AF fill macro, which is what we were using, and that it sends it as a unicast, which is exactly what we want to do. If you're curious about available outgoing message types, you can click on that parameter, and that will tell you that you can send directly to a particular node ID, as is the case here, where we send to 0, the node ID of the coordinator. And remember, that only works in this example because we ensured that the light was always the one forming the network, and so he always has the address of 0. In a real world, there may be lots of lights that each have their own unique addresses. So for a more advanced application, you're probably going to want to have a series of lights that are each represented in a non-volatile way using something called the binding table, and each of them has their own unique index into the binding table. That's why you have options like Ember outgoing via binding, where you send the unicast to an entry noted in the binding table. But since we're trying to replicate, for this example, just what we're doing with the CLI, we're just going to send it directly to node ID 0, as we had been doing before. So we're going to say Ember AF send command unicast, and that does return an Ember status, which you'll note is different than an Ember AF status. So you'll need to have some local Ember status variable that can capture the status of that Ember AF send command unicast call. So we'll call it send status, and we have to do that somewhere in the top of this context. So we'll say send status equals the result of our Ember AF send unicast call. We're going to need the outgoing message type, which we've decided already was the Ember outgoing direct mechanism, which refers to a specific node ID as the target, rather than an index into some kind of table. Now we need to provide the actual address where it's being sent. Just like in our CLI example, we need address 0. Just to make it clearer that this is a node ID, we'll specify it as a fully qualified hex value, 0x0000, and we're going to note that this is the coordinator's address so that you remember why we use coordinator 0, and the fact that this only works because we happen to be sending to the coordinator who happens to be the light in this example. Since these only have 2 parameters, you'll notice that we never had the opportunity to set the 1 and the 1. So where do we put those? And how does that get sent into the message? As it turns out, we need to do that before we do our send call, because by the time we call send, it's too late. So we have to remember that the first one is a source endpoint, and the second one is a destination endpoint. So those would normally go into something called the Ember APS frame structure, which determines the values for certain parameters of the outgoing message. So we're going to need to get a reference to the APS frame that has to do with the global command and set up the source and destination endpoints that go with that global command buffer. So if we go back to the top-level interface and back into the messaging section, we're going to look for an API that gives us a means to set up the endpoints in the APS frame that's connected to the global buffer. You see a number of Ember AF send functions, but we're looking for something that isn't a send function, but instead just manipulates the parameters having to do with the outgoing message. We have Ember AF get command APS frame. That would work. We could use Ember AF get command APS frame to get us a pointer to the APS frame that's associated with the global command buffer. Then we could dereference that, and in that Ember APS frame struct, you will see a source endpoint and a destination endpoint. So you could call that function, go into that structure, set that source endpoint, and then set that destination endpoint. But as it turns out, there is a more direct way to do this, which is to use Ember AF set command endpoints, which just allows you to specify the source and destination endpoint without having to dig into the structure. Note that if you wanted to modify other portions of the APS frame, you would be better off using the Ember AF get command APS frame so that you can modify other members of the struct rather than just the endpoints. So we'll say Ember AF set command endpoints, and the source endpoint comes first. This will be wherever your switch is implemented, and since we only have a single endpoint on the local node, this should be endpoint 1, or even just Ember AF primary endpoint if we want to use the same kind of notation we used on the light to indicate the first endpoint on the device. So Ember AF primary endpoint represents the local implementation of the switch endpoint, and then the remote endpoint is going to be wherever the target node's light endpoint is implemented. Now we don't have an easy way to reference that from inside the switch code, so we're just going to have to hard code 1 here, and remember that that means the light's endpoint. So now we've duplicated the effect of going from endpoint 1 on the source node, the client side, to target node 0 endpoint 1 as the destination node ID and destination endpoint for the server side of this toggle message that we're going to be sending. Now we want to print out the result of that send status, and we're going to use the same kind of macro that we used in the light example, Ember AF on-off cluster print line with send status equals some hex value. And it's a 1-byte value, so we can just use 0x%x and then put in send status as the parameter for that hex value. There's one other thing that you may want to do here to make the code more robust, and that is rather than send the message every time the button is pressed, how about instead we look at making that transmission conditional on whether or not the network is already up. Because we don't want to spend effort building and sending a message when we know it's going to fail, meaning when the device isn't actually joined. So how about we look and see if there's a way to decide how we can check the network status to decide if the node is online before we do all this. Our logic is going to be something like, if not joined, then just ignore the button press and print an error. So we'll say if something, whatever that function is that checks whether we're joined, we're going to say something like Ember AF on-off cluster print line, or really any of these printing areas would work here, but we just need to choose one that we know is turned on. So the on-off cluster print line should suffice here, and our error message is just going to say not joined, ignoring button 1. And then we'll just return without trying to do any of the additional logic. So what is that API that we need to check? So we'll look in the Application Framework API and try to determine what's available to do that. We have attribute storage functions. We have some miscellaneous functions. So in the miscellaneous functions, we have a number of things for setting and getting different kinds of things. So we could do something like Ember AF network state, which says this returns the current network state. And this doesn't require any parameters, but will give us an Ember network status result that we can check against. And our variable statuses are no network, meaning it's not associated at all. Joining network, which means we're on our way in, but we're not ready yet. Join network, meaning that everything is stable and you're properly joined or formed into a network. Join network no parent, meaning you're some kind of end device, but without some kind of responsive parent, or possibly in the midst of rejoining the network. And then leaving network, which indicates that you're on the way out and you're not in a position where you can really send messages. So we're most interested in the status of being joined to the network, meaning that we have a stable configuration that we can use. So we're going to say if Ember AF network state equals Ember joined network, then everything's okay. So we're going to get the inverse of that so that everything's not okay. So if things are not properly joined, we're going to ignore button 1 and return. And if I haven't made any typos, this should all build and work properly. So we can just use F7 to make a new build. And it's going to have to build a lot of new things because when we added a new callback, it also changed the mylight.h file, which is included in lots of different modules. So lots of these modules are now going to have to be rebuilt to produce a new binary at the end. Once that build completes, you should be able to load it to the switch device as you did in the original exercise instructions, and make sure to load it to your switch, not your light. And just like the light, you're not going to want to choose erase chip because otherwise you'll lose all of your joining information that maintains your network membership with the light. So if you do it properly, you should be able to come right back up where you left off because all of that joining data is saved non-volatilely. The key information, the network stack information. So when you reset the switch, it should come right back up just like your light did when you updated your light code. As long as you don't do a full erase of the chip to remove the non-volatile data when you upload the application, the simulated EEPROM area where the non-volatile data is maintained will be still intact after the upload, so you'll be able to come up and the stack will be able to use that previously saved data to resume its network state. Unfortunately, in my case, I had a couple of errors that needed to be corrected. I incorrectly put an equals next to the send status. So if you were reading along and you didn't catch this error, make sure that you fix it now. And the other error I had was that I accidentally misspelled the print line in the Ember AF on-off cluster print line at the end. After fixing all my typos, I should be able to properly build, and then I can load my application to my switch. After loading the switch application, you should now have a console that says your network up again on the switch. So hopefully you have something similar to my view here. The hex number after the Ember network up will likely be different as that's the randomly generated node ID of the switch. Hopefully your light is still up and running and responsive in the console, and hopefully they're both still joined together. If you like, you can do a start capture so that you can see what's happening as we go through the example again. I'll start capture so that you can see the toggle transactions going across. So I'm going to start capture from the switch and the light together. So I'll right click on the group that contains both of them and I'll say Group Start Capture. Now for the test. We'll try to press button 1 and see if the LED turns on. So remember, button 1 is the one that's closer to the green board. So we press button 1 and sure enough, when we've done that, the red LED has gone on, board LED 2, on the light. And we see a message that says toggle on off from 0 to 1, and you saw a toggle message go across and a default response come back, and we saw that default response received. And if we press button 1 again, it should make another toggle which causes the red LED to turn off on the light node. You can even press this rapidly if you like so that you can see it go on and off repeatedly to satisfy yourself that the messages are being processed appropriately. And you should see the captured output reflecting all of those toggle messages and default responses. And according to the printf, you can even see that the STEN status was 00, which if you look up the Ember status enumerations, you'll find that that is Ember success, which is exactly what we would expect to see there. We can even test the error message by taking the switch node offline and trying to send the message. If we type network space leave in the console of the switch, after a second or two, you'll see Ember network down, and that removes the switch from the network. And now if you try to press button 1, you'll find that it says not joined, ignoring button 1, and that's because the Ember network state, the Ember AF network status result, is now no network. So that completes our example, and thanks for following along on this tutorial. If you have any questions or concerns, feel free to reply to this article or submit a case in our community.